Hi everyone, thanks for joining today's session. My name is Amr Saba, Lead Premier Support Architect at BMC. Let's start with the agenda for today. We will begin with quick introduction over containerization and how BMC use this technology. Then we will drill into comparison between Remedy and Helix architecture. Next, we will discuss key phases of migrating from Remedy to Helix. Finally, we will wrap up with a demo over troubleshooting. So, since 2021, BMC Helix ITSM is using only containers. Containers has many benefits. You can think of a container as the same as virtual machine except that it shares its operating system kernel with the underlying host machine, which means it uses less memory, CPU, and disk, and has better performance. So instead of shipping software and you install into a virtual machine like earlier versions, we are now shipping only the whole container, which has all of the software pre-installed so the container can be deployed anywhere and it will work exactly the same way wherever it is deployed. It's much easier to scale up the number of containers handling complex jobs at night or reporting when it's time for a monthly report, and scale it down back afterwards. The real story here is that instead of investing our R&D efforts into supporting and testing our software on multiple operating systems and Java versions and web servers, we are now shipping a container image which works the same way anywhere it is deployed. That means that all of the efforts is now focused on genuine innovation, like native AI capability for instant correlation, proactive problem management, also the progressive web applications for fast, modern, highly configurable user experience. So, because containers are portable, our commitment at BMC here is to support the deployment of our software regardless of whether that is on BMC Helix Cloud, on-premises, data center, private cloud, or public cloud like Amazon, Google, or Oracle. And it will behave the same way. Now, if we have a look into architecture of our old Remedy systems, here we start with the database server and deploy the new infrastructure that will host the virtual machines. Once that's deployed by the infrastructure team, VM team will create the virtual hosts and configure them with connectivity. The network team will create an external load balancer for web traffic and internal load balancer for our ARS servers. At this point, the work of the Remedy team usually starts by downloading multiple installation packages from BMC EBD and upload them to each of the servers, and then we install ARS. In this case, we have 6 VMs, which will be ARS server group. So we have to repeat that process 6 times. Then we can then install the mid-tier servers also 6 times. Then we need also to configure each mid-tier so it gets connectivity through the internal load balancer to the right ARS server. We can then install multiple packages to install the ITSM applications. We would then install and configure other applications like DWB Smart IT and DWB Catalog. Finally, we then have to work through the connectivity between all of these components. So as you can see, and you already know, that this takes a lot of days and efforts. Now let's take a look at the same operation in the new world of containers and automation. If you look into the left corner, you will see the BMC DTR, Docker Trusted Registry, which stores all container images needed. It's possible to pull images directly for your deployment, but it's not recommended. However, you can use a local Harbor repository to store these images. Now there are 2 main components, which is in orange, BMC Deployment Engine and BMC Deployment Manager. BMC Deployment Engine is a Linux-based machine, consists of many tools like Jenkins, Ansible, Git. The other step is the BMC Deployment Manager, which is a script runs over the deployment engine machine which set up the Helix Platform Common Services as the first step in separate namespace in the Kubernetes cluster. The Helix Platform Common Service include number of shared services that many of BMC products can take advantage of, like single sign-on, for example, the identity and tenant management system, and the Helix dashboards. After setting up BMC Helix platform, you can run the deployment engine Jenkins pipelines to install the Innovation Suite applications in a separate namespace. On the right side, this is your external Innovation Suite database, which is outside the cluster and can be Oracle SQL or PostgreSQL. Now let's see an overview of the key phases of migrating from Remedy to Helix. All upgrades from Remedy 2002 and earlier versions will use only staged upgrade method, which means you have to set up a new parallel system. Recent upgrades to BMC Remedy ITSM have been pretty straightforward. Customers have applied the upgrade directly to the production system with short outage or sometimes with zero downtime upgrades. Because we are changing the whole infrastructure, that upgrade in place approach is not possible for upgrades to the new containerized platform, and we recommend the staged upgrade method. So now, how do we get to this fantastic new platform? You would first sync your local image repository with BMC DTR, Docker Trusted Registry. Then you create your Kubernetes cluster and infrastructure. After that, you build your deployment engine machine and install Helix Common Services using the deployment manager script. Then you can restore your external database and deploy ITSM pipelines through Jenkins. After that, you will have your system running. You can then migrate your customizations using Workflow Migration utility to migrate all your AR and CMDB customizations. Or you can use AR System Deployment Management Console or packing lists. You have many options here. After that, you can migrate your data with BMC Helix Data Manager. Now let's jump to a troubleshooting demo to see how can we gather needed logs from Helix environment and do some troubleshooting techniques on Kubernetes environment as well. So first, let's see from mid-tier, how can we download logs? It's in the same old way. We can download the logs from applications, AR System Management Console, Server Group Console, and then logs, view logs. From here, you can select the pod name, which is Platform FTS, because our demo environment is compact sizing. And here you can find all the logs under the DB folder, which you can select any, for instance, AR error log and get file. And then you can display and download from here. Okay. Now let's see the new tool in the containerization environment, which is Support Assistant tool, which can help us to download the logs easier from all pods needed. That is the front page when we log into the Support Assistant tool. Here are our namespace for Innovation Suite applications. Once we click on this, we have a list of all pods in our environment. For example, we have the pod which is running the Support Assistant tool itself. We have for catalog, for DWP, for mid-tier, for OpenFire and Platform FTS and other applications. So if we need to download the log files which are under DB, so we have to go to Platform FTS. We have here a list of directories, AR logs, email logs, bin, PERT, temp, and CMDB logs. So we can specify the time frame which we want to download the logs, for example, the last 1 hour. And from AR logs here, we can download the logs for current pod, or if we have another platform pods in our environment, if we have medium sizing or large sizing, then we might have another platform pods, but in our case we have only platform FTS, so we will download only log from this pod. Okay, so we can save it here. And as you can see, it has all the logs under the DB folder for the last 1 hour. If, for example, we want to download all the logs that starts with AR for the last hour, we can specify the file download pattern. For example, AR star and then download. So as you can see here, we have all log files that starts with AR, and from the RE also reconciliation folder we have this log file because it starts with AR as well. One other good thing here is that we can go to containers inside this pod and see, for example, logs from a specific container. Like we have 3 containers inside this pod. Platform is for the main AR system. Fluent bed is needed for our Helix logging solution, and if packager is needed to collect the logs for the support assistant tool. These two containers are actually sidecar containers, and if we go to platform itself and see processes, we can see the processes that are running, and we can download thread and heap dump as well from here. Just be aware that thread and heap dumps are costly operations and it takes time. We can do the same for mid-tier, for example, pod. We can see specify the time frame, either hour or days. We can specify the directory inside the Tomcat Catalina logs or mid-tier logs, and just download from here. Now our next option, if you are familiar with Kubernetes and you want to do live troubleshooting, then let's see how can we do this. We are logged into our deployment engine machine, which has access to our Kubernetes cluster. And the first thing is I would like to see what are the namespaces that are in my cluster. So simply type kubectl, which is the client tool needed to access Kubernetes cluster, and then get namespaces. We'll see some default namespaces for Kubernetes cluster, and the two main namespaces that we are concerned with is one for Innovation Suite, which is Helix ITSM, and the other one for Helix Platform Common Services. So if I want to list the pods under our Innovation Suite namespace, I have to type kubectl and then get pods -n namespace Helix ITSM. As you can see, the same pods we have seen from the support assistant tool. We can see here the platform, the mid-tier, and all other pods here. And each pod, you can see how many containers inside it and how many are ready. For example, the platform has 3 containers inside it, and the 3 of 3 are ready and running state. If we want to see the logs from platform FTS, for example, we can simply do kubectl logs -n our namespace and then the pod name. Because we have 3 containers inside this pod, so the default, if I go up for you, you will see that the default container is if packager out of 3 containers we have. This one, as we have spoken, is for support assistant tool. This one for Helix logging, and the platform, which is for our air system. So at the end of this comment, I have to specify the containers that I need to see the logs from. So I will run the same comment, but at the end I will type -c platform. As you can see, it is many logs here. We can actually direct the output to a file we have like this, and direct it to temp and say ar logs, for instance, .logs, and then we can read this file simply from here like this. See what's happening. We can also here in this command we can pipe only grep error, for example, if we have any, and see what is this error for instead of going through the whole log file. Also, if we want to log into the pod container itself, the container inside the pod for platform, we can do this by simply, let's first list the pods again for you to see what I'm doing. I will get pods from my namespace, and this is the pod that I want to log into. So I will type kubectl exec -it -my namespace see the containers that I would like to log into. First, let me put bot name and then -c platform and then bash. Now we are inside the pod, inside the container platform. So as we used before in the earlier versions, we can cd to opt bmc air system db folder, and we can list all the files here. We can also list any file from here, for example ar error.log, and see what is there. If I want to copy a specific file from here, from under db, I can exit also, and kubectl, I run this command -n and then cp the pod name and then the path. For example, ar error.log. I want to copy this from the platform container to this path in my local machine. For example, ar error log. Okay, now we need to read this file, so simply highlighting this and list this file. We can see it from our local machine normally and troubleshoot further. One also command which I see useful is to see the current memory and CPU utilization in your Kubernetes cluster. You have to have metrics installed in your environment, so simply you can run kubectl top nodes, which is your cluster nodes, and you can see for each node you have in your cluster what is the CPU percentage and the memory percentage. Also, you can do the same for your pods. So, for example, kubectl get top pods -namespace so you can see here platform FTS consuming this CPU and this memory. One other useful command is to get the events from your environment to understand if there is a problem in your namespace or your cluster. So you can run kubectl get events hyphen namespace. You can see here the last events that happened in your cluster environment. Now, let's see a very useful thing in Kubernetes that everyone like, which is scaling up our deployment. So let's see our pods again, kubectl get pods from our Innovation Suite namespace. For example, here we have mid-tier. We have only one pod. So what we need to do is to scale up this deployment from one pod to let's say 4 pods. So what we need to do is to edit the deployment. So kubectl edit deployment -n namespace, and then type the deployment name. If you go down, this kind is deployment. If you go down, you'll see the number of replicas. That is the parameters that we need to change. So we will go down. Before doing any changes, it's always recommended to do backup as well. So for example, we need to have 4 replicas and save. Now if I get pods again, I will see that there is the old one here and the new 3 pods are creating now. If I see the current updates logs from this pod, I can simply kubectl logs -n and then the pod name. Let's see the logs for this pod, for example, and we can specify a specific container also, mid-tier. It is not yet started, so we can see the logs. So what we can do at this stage is to describe the pod to see what is inside it, if there is any event. So describe pod -n and then the same pod. As you can see, it's creating this container, sidecar or init container, and then the app packager is started, the Fluent bit started. Now it's pulling the image for mid-tier because it is deployed maybe in another worker node which doesn't have the image for this container. We can also see on which worker node this pod is deployed by running kubectl get pods -n my namespace and then -o wide. This command will let you know each pod on which worker node it is deployed. As you can see, for example, the first one is deployed in this worker node. If I highlight it, it's deployed in this worker node, but this one is deployed in another worker node. So it is taking time still. This one is already running in running state. This one also, but there is still 2 containers from the 3 containers are running. Now this has been completed. This is still running. Let's describe it again. As you can see, it says started container mid-tier. It is successfully pulled the image and then created the container and started the container. But it's not yet running Let's see if it's running now. No, not yet. Because let's see the logs to see why the container is not yet ready. It's running, but it's not yet ready. So we can see the logs from this one. Yeah, mid-tier service is not yet up. So the Tomcat started, but you know, sometimes it takes time to be initialized. Let's run again, or we can type -f here to follow the logs. And let's wait to see when it is started. Yes, we can see now. It's trying to connect to our AR server and server startup. Let's see now what is the status. As you can see here, it is ready. 3 from 3. Also, if we would like to scale down again after doing a specific job or so, we can simply edit our deployment again by editing deployment. And go to replicas section. Okay, let's now see what happened when we list our bots. 3 bots are terminating and only 1 replica is running. So if we run our command to list the bots again, we will see only 1 mid-tier user running and 3 out of 3 are ready. One interesting thing here is if we like to restart our mid-tier bot or deployment, Kubernetes actually doesn't let the pod shut down unless there is a new instance is running and in healthy state. So that means if we run kubectl rollout restart -n my namespace deployment mid-tier. As you can see, when I list the pods, the new one is initializing, but the old one is still running. So let's see the mid-tier unique instance ID of this pod, the old one. I will do refresh here. It ends with 3L. So if we keep refreshing, it's the same. And it is this one, the old one. Let's see the new one if it is running. The new one is running, but only 2 of 3 are ready. The old pod is still in running state. So if we keep refreshing here, it will be the same old one. The old one is not yet deleted or shut down. Again, let's do get pods. Still 2 out of 3. We can, as we did before, do logs -n. Let's copy the name of the new pod and mid-tier container. It's not yet up. We can follow this again like we did before. Okay, so it looks to be up now. Let's see if we refresh here, if this ID will be changed. It's loading, and we can log in again. Yes, it's changed. So the new meteor took place. And if we run gitbots again, you will see the new one is running and the old one is terminating now because the number of replicas we have stated in the deployment is only one. So the new one is running and the old one is terminating now after making sure that the new one is ready. In summary, we have explored the benefits of containerization and the reasons behind BMC transition to this technology. We have compared the old and the new architecture, highlighted the key migration steps, and concluded with a troubleshooting demonstration. And here are some additional resources and documentation links that provide further details on the topics we covered today. These references can help you gain a better understanding of the migration process and troubleshooting. Here are also some valuable training resources. Well, thank you very much.